Somewhere inside the sun's glare, a visitor from another star shifted its own future by a hair. Instruments had it on a clean gravitational curve. Then the curve leaned. The motion changed without the plume our models expect. If outgassing did it, telescopes should have caught a small mountain's worth of bright debris. They did not. The skies stayed mostly quiet. The ledger of momentum did not. Either we missed the evidence, or something moved without the reaction mass we count on. This is the 10th anomaly, the one that could force us to redraw the rules. Here is why. The first frames arrive as pale scratches in the noise, the kind that make tired eyes blink twice. Control rooms in the Atacama sit under a thin, cold wind. Hawaii's domes breathe in the dark like sleeping animals. Screens show the sun's arc just below the horizon. A faint trace extends across a CCD. Someone puts a box around it. Someone else checks the astrometry grid. Numbers settle where they should, and then, after new epochs, where they should not. The line between those two feelings is thin. Chills in warm rooms. Coffee cooling next to keyboards. The voice in the room is small and professional. We have motion beyond gravity's script. Interstellar visitors are rare. The first we saw, One-Eye/Oumuamua, rushed by too fast for our instruments to understand more than its shape-shifting light and a whisper of non-gravitational drift. The second, Two-Eye/Borisov, looked and behaved like home, a classic comet with water, dust, and a streaming tail. The third refuses both scripts. It enters our system like a patient line drawn by a careful hand. It brightens, but not the way dust-rich comets do. It hints at jets and offers little proof. There's a difference between unusual and wrong. Unusual stretches a model. Wrong bends a law. If you try to see it without metaphor, think of a rocket climbing with no exhaust. You don't leap to conclusions. You check the air. You ask if the flame is hidden by glare, or if the camera lies. You check again. You pass the same photons through different instruments and different code. You remove what optics can add and what gravity can curve. What remains should be small. It is not small enough. That is where the work begins. We keep a catalog for the strangeness. 9 entries, each a small case file, none a headline on its own. Together they make a pattern you could dismiss as selection bias, until it starts to rhyme. Trajectory. Random interstellar arrivals should cut across the ecliptic at many angles. They come from everywhere, and the solar system is thin. Most will be steep, a few will be shallow lines skimming the planetary plane. This one schemes the plane and does so retrograde, like a car on the wrong side of a quiet highway but hugging the painted line anyway. Expectation says broad scatter, observation says precision. We will test whether survey geometry alone can sculpt this neatness, or whether the neatness is real. Timing. Pure chance distributes encounters with planets across long spans. Here, projected close approaches cluster tighter than comfort normally allows. A near pass, then a pause, then another geometry that increases leverage on its path. When maps put pins that way, it can be nothing, just where our telescopes happen to look most often. Or it can be a pattern shaped by fields we don't usually include. We will check our calendars as carefully as our cameras, and we will try to break the coincidence with new data. Size and speed. First estimates paint it larger and faster than we like for easy explanations. Larger means more mass, which means more momentum to change. Faster means less time to push. If the object is smaller, the bill for the push shrinks. If it's larger, the bill grows. Our brightness to size conversion depends on reflectivity and shape. Porous ice makes one answer. Dark rock makes another. We will keep 3 scenarios on the table, low, mid, and high, and let future measurements move the sliders. Composition. If the gas that escapes is the usual mix, water in charge with carbon-bearing molecules in the chorus, the glow should look familiar. Early spectra lean carbon-rich and water-light. That can be noise. Or it can mean formation far from any warm star, where different ices dominate and grains sinter into strange recipes. If true, the usual dust reflects less light, and gas does more of the work. That would make the plume harder to see. We'll deepen the exposures and seek independent verification. Low water fraction. A few pipelines read a small water signature compared to carbon monoxide or carbon dioxide. For a dirty snowball, that balance is odd. You can bury water under a crust. You can sublimate it where our instruments cannot stare long enough. But if the fraction stays low across epochs, we leave the comfort of our catalogs. We will look for delayed hydration. We will test windows when geometry improves. Polarization. Scattered sunlight carries a fingerprint of particle size and refractive index. At small phase angles, comets tend to show a negative branch in polarization, subtle, but consistent. Here the minimum is deeper than expected, and the angle at which it turns toward positive is off by a few degrees. That could be very fine grains. That could be a surface that's smoother than dust should allow. It could be gas dominating the signal. We log the angles and wait for the curve to evolve with distance from the sun. Brightness and color. Dust reddens comet light as grains scatter more red than blue. In some nights, the slope here tilts the other way. The object drifts bluer. That hints at gas emission lines adding to the blue and ultraviolet, making the color track the chemistry more than the dust. If gas dominates, dust hides, and outgassing could move the body without sparkling the sky. We will test that link by matching color changes to spectra line strength. If the sky respects the timing, the hint hardens. Morphology and the anti-tail. Most tails stream away from the sun. Geometry, rotation, and grain sizes can create illusions, a spike that looks sunward, a fan that seems to defy the wind. We see narrow spikes on some nights, absent on others. A sun-facing element appears in stacks that might be fooling us with perspective. Rare is not impossible. But rare must repeat in a way that tells a story. Time series imaging will decide whether these are jets or tricks of viewing. Sky direction and the wow sector. The arrival direction does not prove anything on its own. People love maps that point to famous places in the sky. History cautions us that stories find patterns where statistics see noise. We include this as a curiosity and then put it on the shelf. If other anomalies survive, we can pull it back down. Not before. 9 files. None decisive. Each one adds a gram to the scale. You could wave the set away as what happens when you look too hard at a single object. You could. But then you meet the 10th. To change momentum, you need a force. For comets, that force is usually jets of gas dragging dust, a small rocket push. The push is weak, but not negligible. Over weeks, centimeters per second compound. Trajectories bend by just enough to matter. The observed offset implies a push big enough to require a debris budget we can't yet find. The math expects a receipt. The cameras find mostly silence. That mismatch is the ledger that refuses to close. So we face 4 possibilities. The first is ordinary but hidden. The plume exists. We don't see it yet. Geometry can hide fragile dust in the glare. The phase angle can flatten contrast until the sky moves. Instruments can miss a diffuse veil if the veil is broader than the field and fainter than the flat fields allow. What we will look for: extended, low surface brightness halos in deep stacks, thin fans that lengthen night by night, color indices drifting toward red as grains accumulate, fragments along the path. If the receipt is there, time and patience will bring it up from the floor. The second is ordinary but efficient. The jets are real and pointed. The gas is not water-driven but CO or CO2, with higher exit speeds and less dust. The geometry of vents and rotation aligns thrust with the way the trajectory needs to change. The result is more delta V per kilogram of ejecta. What we will look for: narrow, repeatable spikes in morphology, periodic modulation in light curves as an active vent rotates. Blue leaning colors with strong gas lines timed to episodes of acceleration. If gas did the lifting, spectra should remember the date. The third is dull and dangerous. We made it up by mistake. Astrometry near the Sun is hard. Background stars are fewer. The point spread function changes with heat and wind. Catalogs differ. The Sun's gravity bends light by tiny amounts that matter in the margins. If we mismodeled any of this, the residual is a mirage. What we will look for: the same position offsets reproduced by different observatories with different optics and different reference catalogs, residuals that shrink when we upgrade code, consistency that survives human error. Artifacts do not line up across instruments for long. Signals sometimes do. The fourth is real and non-standard. Radiation pressure and solar wind can push on very low mass, high-area materials more than on dense bodies. Dust sails, foils of strange composition, electrostatic coupling to plasma environments, these are words that belong at the end of a list, not the start. But lists earn their order by elimination. What we will look for: acceleration scaling with solar distance in ways that match pressure models rather than sublimation, polarization patterns that prefer smooth, sheet-like scatterers over chaotic grains, absence of correlating gas lines when the push grows. A rocket that climbs with no flame invites two checks: is the flame hidden, or is it not a rocket at all? Each possibility comes with tests we can run in the sky we have. None requires a press conference. All require discipline. In the control rooms, the language changes as the stakes sharpen. We favor geometry for now. We disfavor strong dust without tails. The case for efficient gas is pending a higher S/N. The words are dry by design. They keep us from falling in love with a story before the numbers do. Why does a small residual matter so much? Because prediction keeps ships safe. A body that changes course without obvious exhaust is a harder neighbor than one that behaves. For planetary defense, you widen the prediction cone when non-gravitational terms appear. You add terms earlier. You tolerate more false alarms to avoid a blind spot. For planetary science, you update the textbooks on what comets can be when they are not like ours. For SETI, said carefully, under breath, you shift from romance to information. If design is ever on the table, information is the test. Not wonder. Not wishes. Patterns that carry intent. There is also a human reason. The field grows up when its updates get boring and precise. A checklist with fewer blanks. A scoreboard that moves by one box from pending to pass. It looks like nothing, and it changes everything about how we talk to each other, and to the public, when the stakes feel high and the sky is quiet. Now the frame widens. The sun pulls our guest inward. The geometry improves with each night, the elongation grows. Ground arrays in deserts and mountaintops coordinate with instruments above the atmosphere. The next observing window is not a single night. It is a corridor that opens and closes with weather, with moon phase, with the practical limits of people. In that corridor we will look for what the math still expects: a long, faint veil of dust, a coma that grows, spectra that thicken with fresh gas, and positions that fall back in line when we add the right physics to the fit. If the sky answers with debris, the push was natural. If it does not, the question just got closer. There will be pictures for the mind. A thin arc of the sun with a pearl just far enough to measure. A cold line of blue on a spectrograph where carbon should sing if it is doing the work. A polarimetric angle that refuses to sit where the models place it. A light curve that drums or refuses to, telling us whether vents steer or luck does. Every few hundred words in the lab book, a new frame to hold the day together. We should say what we will not do. We will not sell new physics in a sentence. We will not whisper "artifact" when the data survives 6 sets of optics. We will not confuse non-detection with non-existence. Instruments have floors. We will not confuse coincidence with intent. Patterns need thresholds. We will not raise a flag we cannot lower again when better evidence arrives. If momentum moved without mass, we would owe our future selves an apology for not checking harder. If the mass is there and shy, we owe it time. The balance of those debts is the craft. It is the difference between a field that chases headlines and a field that writes standards. Between the first and second weeks of the next run, there is a sweet spot. Elongations widen. Backgrounds darken. Air steadies. Faint debris, if any, would have time to bloom. Observers plan for it the way crews plan launches, stacks of weather models, time slots across continents, backup targets for when clouds pull over the dome. Photons do not care about our hope. They care about geometry and patience. We have both. At some point inside that window, the object will cross a line where small changes cascade into larger questions. A centimeter per second becomes a meter per second becomes a trajectory that deserves a new map. We will know the crossing by the way models stop arguing with each other. We will know it by the way three independent measurements rhyme. We will know it by the way a quiet plot makes a room go quieter still. Hold the idea of the 10th anomaly steady. It is not a claim about aliens. It is not a claim about miracles. It is a statement about a mismatch between what should be visible and what is. The work of part 2 will be to show how we know that mismatch is real, who measured what, when, and how the error bars were tamed. We will walk the timeline from the first streak to the first fit to the first residual that would not die. Instrument by instrument, we will subtract what optics and gravity add, and count what refuses to cancel. Before we go there, one more image, a whiteboard at 3 a.m., equations half erased by the heel of a hand, and a simple sentence pinned in the blank space under everything else: either the plume is late, or the push is cheap. The words are easy to erase. The habit of writing them is hard to earn. Soft cliffhanger: in the coming observing window, instruments from orbit and desert floors will turn to the same patch of sky, probing for dust we might have missed and shifts we can't ignore. If the sky stays quiet, the explanation won't. We begin on a dry winter night in the south. The array in the Atacama works through a long list, field by field, with a cadence tuned to find motion. Each exposure is a few tens of seconds. The next arrives before the eye forgets the last. On one triplet the pipeline draws a diagonal line where stars should sit still. The system flags it with the dull confidence of code, no adjectives, just a score. A graduate student watches the threshold flip from gray to green and, by habit, does not react. She blinks, opens the stamp tool, and drops a box on it. The box holds. Within hours, telescopes on Mauna Kea turn to the same patch, just above morning. The air is not kind, the seeing swells and settles, then swells again. Still, the track repeats. The first quick orbit solutions put the eccentricity above 1. That means not bound. That alone does not make a mystery. The mystery begins when the position after a dozen hours refuses to sit where gravity alone would put it. The logbook keeps the night in short, clean lines. Frame alignment verified. Reference catalog, Gaia. PSF fit holds across field. Residual after two-body fit, present. No one writes strange. They write the numbers, and the numbers are strange enough without the word. Astrometry is craft. To know where the object is, you must know where the background is. Better than that. The background in this game is the star field, locked in catalogs with precisions that make human senses feel sloppy. For each exposure you fit the image to the catalog, accounting for distortion, tilt, and the way optics pull the edges of a field. The star shapes are not points, they are small, soft profiles. You fit those too. Then you subtract what you know about the telescope, the atmosphere, and the sky. What survives should be true on the sky. We did that, and the remainder behaved like a push. Another night, another instrument. A wide-field imager with a different optical train, on a mountain with a different wind. The team repeats the routine from scratch. New flats. New darks. A different code base for centroids. The star catalog is the same, but the path to it is different. If the residual were an artifact, this is where it should die. It does not. The positions shift in the same direction by about the same amount. 4 arcseconds after a week of data. A hair across a football field, too large to vanish inside calibration drift. We add the sunlight's bend to the model. General relativity is small here, but not zero. The sun's gravity curves starlight. Near the solar glare the geometry matters. The code includes the standard correction. It is not enough. You could raise the correction by a factor to see if the residual disappears. You could. But then the same code would fail for objects whose paths we know are clean. We keep the correction where it belongs. Photometry takes a parallel road. If dust is heavy, the light should rise with a certain slope as the object warms. Dust also reddens the light as grains scatter differently across bands. We collect frames in a modest set of filters, G, R, I for the optical, with help in the near-infrared when clouds permit. The pipeline builds a light curve. It climbs faster than a dust-rich baseline would. The color indices drift blueward when the brightness ticks up. A cautious note goes in the log, trend consistent with gas emission contribution. If confirmed. The phrase is important. If confirmed. Spectroscopy keeps different hours. Slits must find a faint moving target and hold it steady as the Earth turns. The first nights only manage low-resolution spectra, enough to see a continuum and chase broad features. The lines where water, CN, CO2, and CO would sing are not strong. Carbon species lean louder than water. The signal-to-noise is thin. The note reads, tentative. We schedule deeper exposures. We call colleagues with time on instruments that live above the weather. We ask them to look for the same lines at the same phases. If gas did the lifting, spectra should remember the date. Polarimetry arrives on a night clean enough to trust small angles. We measure how the light's electric field prefers to line up after scattering off particles or surfaces. Comets show a characteristic bend, negative polarization at small phase angles, turning positive as geometry changes. Our curve dips deeper than a standard dust mix predicts, then shifts toward positive a few degrees late. We do not claim an odd material. We write, minimum deeper than nominal, phase of inversion offset, possible dominance of small grains or gas, repeat needed. Morphology lives on stacks. You take many short images and align them on the moving object so the stars smear into lines and the target sharpens. If a diffuse coma spreads, stacking can reveal it. Early stacks are compact, almost stubbornly so. On some nights a faint sunward spike survives a harsh test. On others it does not. Geometry and rotation can impersonate defiance. We mark it as rare but not impossible. Rarity needs rhythm to earn belief. Time series imaging will either drum a beat or keep quiet. The first week closes with a sober scoreboard. Astrometry, residual survives cross-instrument checks. Photometry, fast climb, blue tilt. Spectra, carbon-leaning hints, water shy, S/N low. Polarimetry, deeper negative branch than usual, phase offset. Morphology, compact coma, occasional spike. None of this proves a plume or the lack of one. Together it says, we should have seen more dust if dust paid the bill. Either the dust is shy, or gas works harder than we thought, or we are fooling ourselves. We try to fool ourselves on purpose. We test selection effects. Surveys are more likely to notice interstellar bodies when they pass near the ecliptic, because that is where we spend more time looking. That could explain the near-planar skim. We run a synthetic population through the same search pattern and thresholding. The simulation recovers more near-plane objects than a uniform sky would suggest. It does not produce the neatness of this track by itself. We mark bias contributes. Does not explain alone. We test the optics. Point spread functions change across the field. If the fit to the star shapes misses a pattern, a slight elongation pressed by wind, a thermal plume across the dome, the centroids could shift in a way that mimics motion. We inject fake sources into real frames and run the pipeline blind. We look for residuals that match our target's direction. False positives appear. They scatter. They do not persist across nights, instruments, and catalog choices. We mark instrumental systematics disfavored as sole cause. We check the catalog. A star grid off by a few milliarcseconds can tilt a solution. Gaia's solutions are not perfect at the bright end or in dense fields. But our field is modest. We swap in alternative releases. We limit the fit to a subset of stars with the best astrometric flags. The residual shrinks by a fraction. It does not die. We mark astrometric catalog issues reduce, not remove. Another observatory calls with their numbers. A private email, then a short video chat with tired faces and bright eyes. They show us their residuals. They match ours within uncertainties. Different hemisphere. Different telescope. Different code. The same sky. The room goes quiet in the way a room does when people choose to say less because they know enough. We have not mentioned the sun enough. Observing near it is not comfortable. Scatter and background hurt. For low surface brightness features, dawn and dusk make enemies of our plans. We widen the schedule to catch the object when the elongation opens. A week later the background gets cleaner. The stacks go deeper. If a delayed dust veil wanted to appear, this is its moment. It does not beyond a whisper above the floor. The whisper is not zero. We will not call it nothing. But it does not grow into the long, steady veil that pays the momentum bill in cash you can see. A different kind of test arrives from orbit. A space-based platform collects time in the ultraviolet, where gas is loud and dust is less so. The pipeline pulls a weak CO feature above noise on one date and not on the next. The timing misses the episode when the astrometric residual is strongest. That miss is not a proof. It is a puzzle piece that does not click yet. We mark inconclusive, schedule more. Inside the control rooms, the language stays conservative. So far becomes a mantra. So far, the position data keep a residual that behaves like a push. So far, the light curve keeps its faster than usual climb. So far, the color leans blue when the object brightens. So far, spectra whisper carbon and whisper less of water. So far, the coma stays compact. These lines sound like delay. They are discipline. They keep us from drawing the line to the conclusion before we finish drawing the line to the data. There is a question some people love to ask early: is the object tumbling? Rotation mixes everything: brightness, gas release, jet direction. We look for periodic modulation in the light curve. We take long sequences to find a beat. If a vent rotates into and out of view, the brightness should drum. The first runs show hints near a few hours, but clouds and scheduling cut the series into pieces. We cannot trust a rhythm that might be weather. We commit to longer stretches as the geometry improves. If vents steer, rotation keeps time. If time stays off tempo, geometry alone does not save the thrust. A second week brings an independent pipeline from a team that prides itself on skepticism. Their code handles outliers differently and weights frames in its own way. They take our raw images and run them through a blind reduction. The curve they return matches the shape of our residual. Their uncertainties are larger because they refuse to cut any frames for quality. This is not a problem. It is a feature of sanity. The match matters more than the error bars, because the shapes agree. We mark residual robustness, supported. In the same span, a radio observatory checks for unambiguous signs of ion interactions. This is a low-probability check, and everyone knows it. Plasma environments can leave fingerprints. They are often too faint, and the beam too large to say anything sharp. The receivers sit in a silent valley and listen. The report comes back quiet. We do not claim anything from quiet here except the obvious: nothing too loud is happening in that band. We file it away among other insufficient. The bias team returns to the ecliptic argument. They show maps that make the near-plane sensitivity visual. They argue that retrograde skimming is not as rare as our instinct says, once you wait by where we can realistically search. The pushback is immediate and calm. Waiting helps, someone says, but it does not align the thrust vector with the residual. Facts can share a room without merging into each other. A note on numbers. When we say residual, we mean the difference between measured positions and the positions predicted by a gravitational model fitted to the data. We include the Sun, planets, and large bodies that could matter. We include relativistic corrections. We include light time. We include the pressure of sunlight as a term that matters for small particles, not for a body with the size we infer. Still, in case the size is smaller than we think, we add a parameter for non-gravitational acceleration that scales with distance from the Sun the way sublimation might. When we add that term, the positions fall back in line. The magnitude of the term implies a push that, if due to outgassing, should correlate with dust and gas signatures. So far, the correlation is weak. We keep a whiteboard of counter-arguments. Position catalog wrong near the Sun. Partially answered. PSF mistracked. Tested, disfavored as sole cause. Relativity term misapplied. Cross-checked. Chromatic refraction. Modeled, minimal in our bands and a poor fit to the direction of the residual. Timing errors. Audit passes, GPS locked, no offset across systems. The board helps in a way hope never does. It shrinks the space of excuses. By the end of the second week, the team meets to write an interim note. Not a paper. A memo for ourselves and our collaborators. It has 4 headings. Confirmed or consistent across independent datasets. Astrometric residual that behaves like a non-gravitational push when modeled without such a term. Faster than typical photometric climb with a blueward tilt during brightening episodes. Polarimetric curve with a deeper negative branch and a slightly delayed inversion phase. Tentative, requiring higher S/N or repetition. Gas lines, CO, CO2, present at low significance, weak or absent temporal correlation with strongest residual epochs. Sunward spike in morphology appears in some stacks, needs time series confirmation and better control of viewing geometry. Disfavored within current sensitivity. Strong, dust-rich outgassing that would create an extended, high-contrast tail within the current observing window. Open tests defined as decisive. Time-correlated spectroscopy during predicted acceleration intervals. High-cadence photometry to search for rotational modulation that could align vents and raise efficiency. Deep, wide-field stacks to find ultra-low surface brightness debris we may have shaved off with processing. We keep the memo short. It could have been longer. Longer would not make it better. The last sentence reads, either debris appears on schedule, or the hypothesis ledger opens a new column. No one signs the line with a flourish. They initial it like adults. Between nights we review the tools. One team rewrites the centroiding to downweight saturated stars that can pollute the fit. Another rewires the way the code handles slight drift within an exposure. A third lowers the detection threshold but raises the false positive filter to keep humans from drowning. The work is dull and exacting. This is what it takes to earn a claim. Not new adjectives. New margins. A day brings clouds where we wanted clarity. A night brings cold that steadies the air and gives us a gift. The next stack deepens beyond any before it. The surface brightness limit nudges low enough that a modest, old-fashioned dust coma would be obvious. The stack shows nothing obvious beyond the compact core, plus a wisp that looks like a trick until it reappears at the same position angle in a second independent stack. We put both images side by side and pass them around. Pending, someone says. We add pending to the caption like a kind of prayer. Across time zones, a different team with a different telescope pulls a light curve that, finally, beats a rhythm. Not strong, but steady enough to fit a period within broad error bars. If real, the rotation period would be a few hours. That would allow a vent to spend a meaningful fraction of time aligned with a thrust vector. Efficiency would rise. The required mass loss would fall. If the mass loss falls far enough, the dust bill might drop below detectability within current limits. If. That word does a lot of work. We plan a dedicated run to confirm the period or retire it. Another call. A space telescope team schedules a narrowband filter centered on a CO line during a predicted acceleration interval. The window is short. The roll angles are not ideal. Still, the request goes through. The message reads, if gas did the lifting, spectra should remember the hour. It is a tidy sentence. The schedule is tight. We align ground-based astrometry to bookend the orbital fit around the same time. If lines rise and the residual rises, we can say the words, time correlation, without flinching. If the line stays flat while the residual grows, we will say, disfavors. If both stay flat, we say, insufficient. This is how we speak when we grow up. We are not alone in wanting drama. Journalists call. We do not take all the calls. We do not let the cameras into rooms where numbers are still wet. When we speak, we use the slow words, consistent with, disfavors, insufficient to conclude, pending. We prefer dull accuracy over bright speculation. We owe the public thresholds, not adrenaline. By the third week, the community knows the outline of the case. Private notes turn into preprints. Not claims, methods and status. The argument, such as it is, focuses on the gap between the push the astrometry wants and the plume the cameras have not seen. We are not arguing about the math. We are arguing about the receipt. Part 3 will price the push more explicitly: mass, speeds, geometry, efficiency. We will ask how many kilograms at what exit velocity it would take to buy the observed delta V, and whether that bill should show up in photons bright enough for us to see. Before we leave this room for the arithmetic, one more scene. A young observer steps out of the control building and looks at a line of light along the horizon. The dome behind her exhales warm air into the cold. She holds a notebook with a checklist where most boxes are filled and a few are not. The few are the only ones that matter. She goes back in, sits down, and draws 3 boxes at the bottom of the page, side by side. She writes under them, morphology, lines, time. She smiles without showing teeth. The night will decide how many of those boxes get a check before dawn. The next run overlaps the planned spectroscopic window. If the gas lines rise on cue and the residual bends in the same hour, we move one box from pending to pass and the bill starts to balance. If they do not, we carry the mismatch forward, into numbers. In celestial mechanics, momentum is the one ledger that never forgets. Every motion, planetary, cometary, human, pays for its change in momentum with something. For rockets, it's fuel. For comets, it's vaporized ice. For everything else, there's no free lunch. Dr. Edda Nielsen, head of dynamics at the Nordic Space Center, draws a short line on the whiteboard and labels it delta V equals 2.8 mm/s superscript 2. It doesn't sound like much, she says softly, tapping the board with her marker. But over 100 days, it's everything. To move a body tens of meters across after a few weeks, it would need a steady push, equivalent to a whisper of gas leaving the surface, if that surface still behaved like ice and rock. The mass estimate, drawn from brightness and albedo models, sits between 2 times 10 and 8 times 10 kilograms. A small mountain of frozen dust, roughly 50 meters across. If the residual acceleration came from outgassing, then Newton's math offered a simple test. You can't cheat momentum, says Nielsen. If the object speeds up, something must slow down. The mass leaves, or something external pushes it. They start with conservative parameters. Suppose CO or CO2 jets erupt from the sunlit side. The thrust would be weak but measurable. For the observed delta V, they calculate that the comet would have to lose about 20 tons of material per hour. That's roughly 2 truckloads of ice evaporating into space every 60 minutes. Yet the telescope saw no haze, no thick tail, no glitter of debris that would betray the loss. The missing receipt. In Mission Control's Cooler Light, an intern scrolls through comparative datasets of historical comets. The pattern is undeniable. When a comet pushes itself with gas jets, it glows, every time. Even 67P/Churyumov-Gerasimenko, barely active by cometary standards, showed clear, expanding fans under the Rosetta cameras. Rosetta's jets gave a non-gravitational term of 10 to the -5, says one analyst, voice measured. And that produced visible ejecta. Our guy's stronger than that by an order of magnitude. Yet quieter, another replies. The numbers go on the board. Comet 1P/Halley, delta V is almost equal to 0.1 mm/s superscript 2, plume brightness magnitude -1. Comet 67P, delta V is almost equal to 0.04 mm/s superscript 2, dust-to-gas ratio is almost equal to 5 to 1. 3I/Atlas, delta V is almost equal to 2.8 mm/s superscript 2, visible dust is almost equal to none. Silence follows. Someone breaks it with the obvious. Either it's losing mass in a way we can't see, or it isn't losing mass at all. The story narrows to chalk and numbers. In a world where every motion leaves a trace, this one insists on being invisible. The team begins modeling possible thrust vectors, some from the day side, others from rotating vents that might cancel each other out over one spin. A simulation plays on screen, a spinning ellipsoid bathed in digital sunlight. Jets flare and fade as it turns, a ghost dance of physics. When properly tuned, the digital object reproduces the same orbital deviation seen in reality. But there's a catch. To match the observed trajectory without visible dust, the simulated jets must expel gas 3 times faster than any natural cometary vent has ever done. Even CO outflow can't get you that velocity, Nielsen says. You'd need superheated gas or micronozzles, something engineered for direction. The word engineered hangs in the air too long. Someone clears their throat. The conversation moves on, but the silence leaves its print. To keep faith with physics, the team turns back to comparison. They pull data from Hale-Bopp, the Great Show comet of 1997, bright enough to cast shadows on Earth. It shed an estimated 200 tons of dust per second at perihelion, yet its acceleration was barely perceptible. By contrast, Atlas's motion suggests a similar thrust with 6 orders of magnitude less visible dust. The math reads like parody. Dr. Yoon, the spectroscopist from Seoul, murmurs, if the same thrust comes from almost no ejecta, the energy source is either deeper, or stranger. They test every natural idea that doesn't insult the laws of thermodynamics. Highly volatile ice is buried under a crust that releases pure gas without dust. Possible, but requires a composition rare even in outer Oort bodies. Rotational venting, jets firing intermittently, their debris hidden by phase angle. A stretch. Outgassing of supercritical CO2 through nanopores in metallic dust. The physics says yes, the probabilities say no. The simulation still wants more energy than the sun's warmth can provide. When you multiply mass loss by exit velocity, you get momentum. When you multiply it by temperature and latent heat, you get energy, and here the sums collapse. Even with optimistic assumptions, the power required to maintain that push would exceed the absorbed solar flux by a factor of 3. The object would have to radiate less heat than it receives while converting the remainder into thrust, an efficiency no natural body could sustain for long. So either the mass is smaller than we think, Nielsen concludes, or something else is helping it move. If it were smaller, perhaps radiation pressure could account for the acceleration, the same gentle push that moves sunlight sails. But to respond that strongly, the body would need a mass-to-area ratio close to that of a foil, not a rock. That would make it less a comet and more, something else. No one says it aloud, but the word is there again, engineered. The skeptic's room. Across the ocean, in Pasadena, a counterteam convenes in a conference call. Their job is to break the anomaly. Momentum conservation still rules, says Dr. Les Gordon, voice crisp through a bad connection. You can't have thrust without reaction mass, unless you're coupling to the solar wind or using some exotic mechanism. He gestures toward his own numbers. Let's not forget the mundane. Maybe we misjudged reflectivity. If it's brighter, it's smaller. Smaller means radiation pressure counts more. His team builds a shape model, an oblate body, reflective like frosted aluminum, tumbling on 3 axes. In simulation, radiation pressure alone produces a drift similar to the observed one. It fits, but too neatly. The required reflectivity is absurdly high for natural dust. A pause. Someone mutters, "You'd have to polish it." Laughter, thin and nervous. The conservation test. Nilsson's team runs a sanity check with basic physics. Mass, m4 times 10 kg, nominal. Acceleration, a 2.8 times 10 superscript 3 m/s superscript 2. Force, Fm times a is almost equal to 11,200 n. To produce that force with gas jets, using CO2 at 500 meters per second exit velocity. F equals times V equals 11,200/500 almost equals 22 kg/s. That's 80,000 kilograms per hour, around 80 tons of material every hour of activity. If so, each hour should fill space around the comet with a faint coma billions of particles thick, visible in every deep exposure. There is no coma. The images stay stubbornly clean. Even if they have the mass and double the gas speed, the dust visibility should persist. It doesn't. The numbers don't lie, but they don't tell a comfortable truth either. They start calling it the missing receipt. A shorthand for the unbalanced equation, acceleration without exhaust, power without proof. Dr. Yoon writes it on the top of her notes in thick pencil. Every push leaves a scar. Where is yours? The team revisits every corner of physics, thermal lag, subsurface vents, electrostatic dust lift. Nothing cancels the debt completely. When the dust won't appear, Nielsen turns philosophical. Maybe, she says, it's not that the gas is missing. Maybe it's that our eyes are wrong. Meaning, maybe the spectrum lies outside the window we watch, the ultraviolet or the infrared where our instruments don't yet look deep enough. Meaning, maybe we're staring at the receipt in invisible ink. They submit requests for longer wavelength data, but the bureaucracy moves slower than the object itself. By the time approval comes, Atlas will already be deep into the outer system, trailing its mystery behind. In a break room filled with cold coffee and warmer arguments, the conversation drifts to Oumuamua, the first interstellar visitor. That one, too, had shown a small push with no visible exhaust. The official papers blamed outgassing of volatile hydrogen, invisible to telescopes. Critics called it a stretch. Others whispered about light sails. And now, history repeats, louder. A young astronomer scrolls through both trajectories, overlaying the acceleration profiles. The resemblance is eerie, both start negligible, rise gently near perihelion, and fade in perfect smoothness, as if controlled. Same pattern, she says. Nielsen leans closer. Not same amplitude. But same shape. Close enough to make you wonder. The room grows still. Outside, dawn pulls over the desert sky like a pale curtain. Building the red flag table. By the end of the week, a formal report begins to take shape, a living document shared across 3 continents. It lists evidence in columns: expected, observed, discrepancy. Parameter expected, for cometary jet, observed discrepancy outgassing rate, 20, 100 kg/s, 0.1 kg per second, upper limit. Times 200 short visible coma strong none detected full absence dust color red slope neutral blue inverse momentum balance matches jet direction off axis by 17 degree unexplained profile pulsed continuous no periodicity total energy budget less than or equal to solar input greater than or equal to 3 times solar input impossible. Red flag, Nielsen mutters. That's what this is. She doesn't mean scandal. She means physics breaking its own habit of being predictable. For a moment, someone half jokes about non-local forces and reactionless drives. It gets a laugh, then dies fast. The culture here worships data, not fantasy. But fantasy often sneaks in wearing a lab coat. Still, they explore one last angle: electrostatic lift. If the object's surface carried a strong charge differential, interaction with the solar magnetic field could, in theory, provide a faint thrust. Yet calculations show it would need voltages near 1 million per square meter. Unrealistic for a body made of rock and ice. Another model uses asymmetric radiation absorption, one side dark, one reflective, creating a Yarkovsky-like effect. It fits partially, but only if the rotation axis sits at a perfect orientation, something they cannot confirm. At best, this would give 1/3 of the observed acceleration. The rest remains unaccounted for. Physics lets you fudge, Gordon remarks over video, but not that much. Emails leak between institutions. Someone writes, "We may be staring at the first interstellar object with controllable dynamics." Another answers, "Or the first with physics we don't understand yet." Both statements can be true. Outside the echo chamber, the public knows only fragments, press releases about unusual acceleration, the phrase wrapped in cautious optimism. Inside, tension tightens like wire. Every new dataset either adds noise or deepens the gap. The community doesn't yet agree on what to call the phenomenon. Some prefer residual thrust. Others, non-gravitational term. The younger postdocs just call it the ghost push. To understand the absurdity, one must remember scale. At its closest, Atlas was 2 astronomical units from the Sun, 300 million kilometers away. At that distance, even a single pixel's shift across days means kilometers of travel. To extract that motion from the static noise of stars requires algorithms that treat light like fingerprints. Yet across every dataset, from Chile to Hawaii to orbit, the same deviation appears, synchronized within margins tighter than a human hair seen from 10 kilometers. Coincidence loses ground. Different telescopes, Nielsen whispers one evening, watching the residual plot overlap like matching heartbeats. Different people, same error. That's not an error anymore. By now, the metaphor has taken root in every conversation. They talk about physics the way accountants talk about fraud. Every comet's motion should balance its books: mass out, momentum gained. Atlas's ledger shows a surplus of motion and a deficit of exhaust. The report's first draft closes with a single paragraph that reads like the calm before an argument. The conservation of momentum remains valid. Yet unless unseen mechanisms operate, the observed trajectory of 3I/Atlas implies an energy efficiency incompatible with known cometary physics. The cause of this imbalance remains under investigation. In other words, we can't explain it, but we can't ignore it. Late in the night, Yoon sits alone with the simulation still looping. The digital atlas turns in silence, gas jets flickering like phantom veins. In the corner of the screen, a small overlay displays the cumulative delta V, ticking upward every second. "Where does it come from?" she murmurs. Nielsen, passing by, stops. "From the numbers," she says. "No," Yoon insists. "The numbers come from it." It's a small exchange, swallowed by the hum of machines. But it captures the unease of a field looking into a mirror that doesn't blink. The closing session that week becomes less a meeting, more an oath. They agree on 3 things. The acceleration is real. It requires thrust. The observable thrust mechanism is missing. Everything else, composition, cause, and comfort, remains open. They move to formalize the math into a public report, a conservation ledger. Tables of delta V, mass, power, radiation pressure. Each cell carries not just numbers but quiet disbelief. The lead paragraph ends with a line that feels too poetic for a scientific paper, but no one edits it out. Whatever moved it did so gently, but left the universe slightly out of balance. Setting up the next step. Now, the next chapter will demand confrontation between theory and evidence. If the math is right but the sky disagrees, one of them must yield. They plan a new round of observations, polarimetric checks, long-range thermal readings, high-sensitivity spectroscopy, to look for traces that might still balance the equation. If nothing turns up, they'll have to entertain a 4th column in their red flag table, one not labeled error or natural, but something in between. The team schedules their decisive run. The instruments are tuned, the models ready. If the upcoming data reveal the missing receipt, the faint ghost of exhaust they've been chasing, the ledger closes and physics breathes easy again. But if the sky stays clean, the debt grows, and so does the question no one yet wants to ask aloud: what kind of traveler pays no price for motion? The building breathed like a living thing, air handlers sighing, monitors ticking, cable trays humming a mechanical lullaby. Inside this nighttime aquarium, a dozen faces watched numbers climb and settle. The object hung beyond the glass of Earth's sky, still moving as if a hand, unseen and patient, guided it. We had done the math. Now we had to face the sky. The plan was simple in its cruelty: set 3 independent litmus tests that natural thrust could not escape if it were real. If a comet pushes itself, it leaves signatures. If the push is a mirage, the signatures fail. If something else is happening, those signatures mutate in a way that tells on the lie. 3 tests. 3 attempts to make the universe confess. Objective: if the residual acceleration is driven by volatiles, CO, CO2, H2O, then the near UV through near IR spectrum must carry their byproducts, CN at 388 nanometers, the Swan bands of C2, the broad water fluorescence, or at least a thin CO/CO2 continuum. Even when dust hides its face, gas glows by the rules of quantum mechanics. Execution: the spectrographs already in play, 2 in Chile, 1 in Hawaii, were retuned for sensitivity over interpretability. Band passes widened. Integration times crept riskilong for a moving target. A narrow slit raced across the sky to stay married to a point that would not stop changing its mind. Dr. Yoon stood over the console like a violinist. "Noise eats your faith first," she said, half to herself. "So we feed it noise until it chokes." We stacked exposures, subtracted fringing, pulled the weak heartbeat from the fluorescence continuum. The team compared to templates: hail, Bob's fierce CO-driven breath, 67 ps dust-rich simmer, even the frail whisper of small centaurs warming as they drift inward. Each template carried familiar ridges and valleys in wavelength space. Result: a blank that wasn't quite blank. A continuum flatter than dust and smoother than gas, with only the faintest, arguable shoulders where CN would sing if it were present in strength. We put numbers on it, upper limits for CN, for C2, for H2O. The limits weren't absolute, nothing is in astronomy, but they were stubborn. Natural thrust should have sung louder. It didn't sing at all. Yoon circled CN on the report and wrote, detection threshold by time 7 at 5 sigma. Then she underlined the 7, as if underlining made it less absurd. Objective, if momentum leaves as matter, somewhere a camera sees its wake. Not necessarily a grand tail, phase angle can hide miracles, but a coma, a fan, a lopsidedness that betrays what the nucleus expels. Execution, the imager in Chile went wide, the one in Hawaii went deep. We scripted sequences to exploit the object's rotation period, still provisional, but caged between 6.5 and 7.1 hours. Over multiple nights the pipeline performed a cruel surgery, reprojecting in the object's frame, co-adding, and subtracting stars until only the traveler's light remained. We played tricks to pry open the dark, PSF subtraction to remove the point spread core, unsharp masking to tease out halos, isophote mapping to quantify shape. The images that emerged could have belonged to an asteroid, compact, star-like, unadorned. Then, at ludicrous stretch, a thin suggestion, no more, of a hairline extension opposite the sun. We measured its position angle, we measured our own superstition. Could be a ghost, the imager said. Or a whisper, Nielsen replied. Result, the formal fit returned a coma profile consistent with an inactive body to within the limits of our seeing. The hairline fell below our reliability threshold. If dust was there, it hid with the skill of a thief and the luck of a saint. Objective, dust scatters light with a preference. The polarization phase curve, how the degree of polarization changes with angle, betrays particle size, composition, and abundance. Comets lie in families, their curves rhyme. A dustless rock, or a bright sail, leans differently under sunlight. Execution, we pointed the polarimeter and let the sky turn. Across a spread of phase angles, we sampled the object's light again and again, rotating the analyzer, calibrating against well-behaved standards. Polarimetry is the art of measuring a gesture the universe barely makes, it punishes impatience. On the board, Gordon's team had plotted canonical curves, the negative branch near small phase angles common to comets, the rise and flattening for larger. We layered Atlas over the choir. Result, the curve refused to join in. The degree of polarization hovered low, with an inflection too shallow for a dust-rich coma and too smooth for a bare Lambertian rock. It sat between categories, as if the surface acted like a fine, coherent scatterer, smoother than dirt, rougher than foil. Yoon chewed the cap of her pen. You know who scatters like that? She asked no one in particular. Sintered metallized fabric. Or very fine frost on a non-porous substrate. The room did not answer. It had learned not to answer those kinds of sentences. The decision tree. We pinned butcher paper to a wall and drew a tree big enough to shame a forest. Each branch held a hypothesis, each leaf, a testable consequence. Root, residual acceleration is real, validated by independent astrometry. A. Classical volatile jets, CO/CO2/H2O. Spectral lines/bands present above threshold not observed. Dust coma/tail at expected levels not observed. Energy budget less than or equal to solar input violated. Disfavored. B. Geometry hides activity, phase angle/rotation bias. Polarimetric curve comet-like under rotation average not observed. Time variable asymmetry aligned with spin not observed. Nightly phase geometry predicts swing in tail PA not observed. Disfavored, but not impossible. C. Radiation pressure on high area to mass body. High reflectance/low density required implies sail-like morphology. Polarimetric signature low and smooth partially observed. Light curve elongated/rotation damped inconclusive. Possible with extreme assumptions. D. Thermal recoil, Yarkovsky-like/asymmetric thermal emission. Thermal IR excess phase lag correlated pending. Spin axis orientation constrained by light curve pending. Magnitude, 1/3 of observed delta V under plausible materials likely insufficient. Unlikely as sole driver. E. Electromagnetic coupling, charge/solar wind/Lorentz. Requires unrealistic surface potentials disfavored. Variability with solar wind conditions to test. Polarimetric/IR signature neutral consistent. Theoretical long shot. F. Systematic error/astrometric bias. Multi-instrument redundancy fails. Residuals consistent across pipelines fails. Timing/clock biases ruled out. Rejected. We stood back in an accidental silence that felt ceremonial. The tree said what we didn't want to say plainly: A and B were falling away. C. Radiation pressure acting on something with more sail than stone, refused to die. D could play a supporting role, E was a dare to the imagination, and F had lost its last friend. Leave some humility in, Gordon said on the call. We may be throwing darts at a moving wall. But he didn't object to the colors we used to shade the branches. The cool blues of disfavor crept over most of the paper. A wary, blinking amber occupied C. Nielsen tapped it. The one we don't like is the one the sky likes, she said. So we stop liking or we change the sky. We wrote the section that no one enjoys writing, the part where you line up what you expected and what you actually got. And you do it with a voice that refuses drama. Spectra, no robust gas signatures. Upper limits below what natural jets would demand to produce the measured thrust. Morphology, no resolved coma at expected radii, tail-like features indistinguishable from background structures at aggressive stretch. Polarimetry, low, smooth degree of polarization inconsistent with dust-rich comi, suggests coherent or fine-scale scattering. Energy, power implied by acceleration exceeds plausible solar input for a natural vent by factors of 2 to 3, unless area-to-mass ratio is anomalously high. Say anomalously once, the editor advised, not 3 times. We obeyed. The point stood. We appended an ethical footnote: comparisons to prior interstellar objects, Oumuamua, are heuristic, not evidentiary. Similarities in trend shape do not imply identity of cause. We were not going to let our own ghost stories write the paper. If a lawyer had defended natural outgassing, geometry would have been their case. Ladies and gentlemen, the dust is real, you simply saw it poorly. So we gave geometry its day in court. We reconstructed the phase angle history for each observing night, plotted against predicted dust fan orientation and synodic rotation period. If the coma hid, it should have peaked out at certain angles. If vents pulsed with rotation, asymmetry should have wobbled the photometric centroid. Neither footprint appeared. The centroid was stubbornly well behaved. The isophotes, contours of light, remained concentric like rings in a tree. Is it possible we're staring straight down a jet? The graduate student asked. Possible, Nielsen said. Like winning the lottery while being struck by lightning. We kept it on the table anyway. Nature enjoys making statistics weep. Radiation pressure had lurked at the edge of every conversation, a smug ghost with clean hands. We'd tried to exorcise it with reflectivity arguments and light curve constraints. It kept returning with the same proposition: if the object's area-to-mass ratio were high, thin and broad rather than dense and round, the sun itself could be the engine. No exhaust, no dust, just light pushing on a skin. We tested the idea with a parametrized model, a flat plate with specular and diffuse components, tumbling or stabilized, under solar flux. We tuned its albedo to the polarimetric hints, we set its density to the threshold at which rocks become metaphors. The result was an uncomfortable fit. Not exact, but plausible in ways our pride resented. Specular fraction at 30%, the modeler reported. Albedo around 0.6. Area to mass ratio, 5 times that of a millimeter-thick foil, unless we're overestimating the mass. Gordon whistled into his mic, make it a sandwich core. Thin face sheets, sparse interior. You can fake stiffness cheaply at those scales. We didn't type the word engineered. We also didn't delete it from anyone's head. If electromagnetic coupling had any chance, if the solar wind and magnetic field could coax motion from a charge-bearing surface, then the object's acceleration should whisper in time with space weather. We aligned the residuals against solar wind speed, proton density, and interplanetary magnetic field rotations. The correlations were weak to non-existent. If the sun's charged breath played a role, it did so as a murmur under a louder song. Back pocket hypothesis, Nielsen said. But the melody isn't there. Decision trees end in outcomes or in deadlines. Ours ended in a date. The sky was kind enough to give us a window. Over the next 6 weeks, geometry would swing in our favor, phase angles to stress the polarimetric response, a Sun-Object-Earth alignment that maximized the measurability of any feeble dust fan, thermal baselines long enough to observe lag if thermal recoil mattered at all. We drew lines on the calendar. November 12th to 19th for a polarimetric sweep, when the angle would cross the shallow shoulder and any dust would reveal its telltale negative branch. December 4th to 9th for deep imaging to a coma radius twice our previous limits. December 16th to 19th for synchronized spectroscopy and narrowband imaging to slam shut the gas question. 3 litmuses. One after another, Yoon said. It won't be dramatic. It will be decisive. We wrote down our thresholds like vows. Spectra pass, any detection of Cn, C2, or H2O at 5 sigma consistent with a mass flow sufficient to supply the measured delta-V natural jets favored. Morphology pass, resolved coma or fan with surface brightness gradient matching expected gas/dust coupling natural jets favored. Polarimetry pass, phase curve aligns with comet family curves within 1 sigma after rotation averaging natural jets favored. Anything less than 2 passes meant we lived with a different world. Between the rooms with locked doors, someone had to speak to the world. The press office drafted cautious language. We are conducting a multi-wavelength campaign to evaluate whether subtle, hard-to-detect outgassing can explain the observed non-gravitational motion. Early indications are inconclusive. We signed off because it was true, and because there are times when truth needs to be a soft thing. In private, we drafted the harsher paragraph we might need later. If the campaign fails to observe concomitant gas or dust signatures at levels commensurate with the required momentum exchange, we will consider alternative force models, including enhanced radiation pressure on high area-to-mass structures. We did not include the word artifact. The world did not need our guesses, it needed our measurements. The first night of the polarimetric sweep nearly died to clouds. In Chile, a thin cirrus laid lace over the stars. In Hawaii, the wind screamed past the dome as if trying to pry it open. We worked anyway. The analyzer rotated. The star fields marched. The data fell into the pipeline with the sick rhythm of a heart that knows it is being watched. At 3 a.m, the Chilean feed flatlined into white noise. Power dip, came the voice on comms. Grid wobble. Backups on. We waited through 13 long minutes without images, then the frame reappeared, clean, crisp, a fractional shift like a breath caught. We filled the gap with an internal joke about the universe being camera shy. The laugh didn't travel far. By dawn, we had enough to stake the first tent pole. The preliminary curve still ran low, still too smooth. Dust refused to lean the way it should. We did not call it. We are not that kind of story. As the results trickled, the decision tree changed color. Spectra, still null. Polarimetry, sliding farther from comet curves. Morphology, stubborn as stone. Under the fluorescent lights, our butcher paper looked like a battlefield after the smoke had cleared, blue crosses over fallen hypotheses, amber circles around survivors we didn't trust. Gordon, across the world, sounded tired and strangely tender. Sometimes, he said, we keep a branch alive because killing it would make us lonelier. Nielsen set down her marker. Sometimes we kill a branch because keeping it would make us brave, she answered. Neither line was the science. Both lines were the truth. By the end of the second week, the working consensus was a shape with edges we did not like to touch, a high area-to-mass ratio body behaving as if light itself were steering it, while all classical exhaust channels stayed silent below detectability, and all geometric alibis failed. We had not proven anything conclusive. We had cornered ourselves into being intellectually honest. So we did the next honest thing, we designed decisive tests to make our least favorite survivor eat or starve. Rotational damping check. A sail wants stability. If radiation pressure is king, the rotation should drift toward states that minimize torque. We scheduled a dense photometric run to watch for damping signatures. Specular glint search. A plate will flash if it rotates through specular geometry. We aligned observers across latitudes to maximize the chance of catching synchronized microglints. Thermal inertia constraints. Using long wavelength windows, we hunted for phase lag in emitted heat that a thin structure would not store. If we failed to find damping, glints, or thermal lack, the sail hypothesis would bleed. If we found them, well, we'd need new adjectives for uncomfortable. We formalized the scoreboard for the campaign that would soon be public enough to be argued on kitchen tables. Cometary jets, fail, pending final deep spectroscopy. Geometry hiding activity, fail, pending last-ditch low-phase sessions. Radiation pressure dominance, pending. Thermal recoil augmentation, pending. Electromagnetic coupling, pending, low prior. Systematic error, fail. We weren't betting people. But if we had been, the odds were moving. Someone, no one claimed credit, mocked up a slide with a calm title, If C is True. It listed practical consequences, not philosophical ones, update ephemerides with a non-grav term that varies with cross-section, warn navigational services about increased uncertainty cones, prep public material explaining radiation pressure to audiences that still confuse comets and meteors. Yoon added a line at the bottom, do not name what you cannot prove. We nodded. The room did not feel brave. It felt responsible. That was better. On the last night before the deep imaging block, the object moved through a field that matched one we'd used weeks earlier. The frames could be blinked, then and now, same stars, same seeing, same exposure. We did it out of habit and because comparative anatomy comforts the scientific soul. The blink revealed nothing startling, just the tiniest tightening of the residuals when we applied a toy model that let the cross-section oscillate with a slow, stabilizing drift. The software loved the toy. The toy, in turn, loved the sun. Don't fall in love with a fit, Gordon warned. We're not, Nielsen said. We're learning how it wants to be wrong. We assigned no press release to that night. We saved our voice for the days that count. The team rehearsed the data handoffs. A small army of script stood ready to chew on photons the instant they touched disk. We labeled drive arrays with names we'd remember under stress, Morse, Turing, Noether. We triple-checked the clocks. We wrote macros that would populate the pass, fail, pending board live, in-house only. We told ourselves, firmly, that whatever the board said, we would believe it, especially if we disliked it. Outside, the calendar slid forward with the indifferent grace of celestial mechanics. The object's path angled outward, toward the kingdoms of the giants. Our window would close behind it like a door on silent hinges. On the eve of the deep imaging run, a routine crosscheck tripped a small alert. The astrometry residuals, when folded against solar elongation and Earth object parallax, showed a subtle, but coherent, phase-dependent modulation. It was the kind of signal you see only after you've stared long enough for your eyes to manufacture ghosts. But it held when we changed pipelines. It held when we shuffled the timestamps. It held when Gordon's team, muttering, rebuilt the fit from scratch. A modulation like that could be nothing. It could also be the shy first hint of cross-section control, the posture of a body that presents more face to the sun when it needs more push, less when it doesn't. "Don't say it," Yoon whispered. "No one's saying it," Nielsen replied. We flagged the pattern pending. We put it on the board in small font. And then we looked at the week ahead as if it were weather sweeping in across a dark sea. If the 3 litmus tests stay silent, the decision tree will point where none of us wanted it to. If even one of them speaks in the old, familiar language of comets, we'll exhale and let nature keep her crown. Either way, at the far edge of this window the object's track will bend toward colder light, and the questions will either narrow or multiply. For now, the domes will open, the analyzers will turn, and the universe will do what it always does when asked the right question: it will answer, quietly, exactly, and without apology. Before sunset we moved like stagehands, checking slit wheels, warming detectors, snapping desiccant packs into housings with the familiarity of surgeons laying out instruments. By nautical twilight the rehearsed quiet took over, the red glow of status LEDs, the soft mechanical throat clearing of shutters, the steady metronome of guiding corrections clicking across headsets. On the wall of the control room, the scoreboard we had sworn not to make gaudy still looked like a game show. Pass/fail/pending, 3 columns, each tied to a litmus test and 2 auxiliary models. A row beneath track trajectory fit residuals in milliarcseconds, updating every 5 minutes with an almost petulant chime. Across the top we'd taped a tiny paper calendar, days crossed with a felt-tip pen. 11, 12, 13, counting outward toward winter and the hinge the sky had arranged for us. We didn't speak about stakes anymore. Stakes were the air. November 12, a sky that would not help. Chilly, 2:17 local. A high cirrus poised like a gauze mask between telescope and object, the seeing obedient but soft. We started the polarimetric sweep anyway. The analyzer rotated through position angles like a tiny lighthouse. The object sat where the ephemera said it would, a prim dot stepping between field stars. Angle 90. Integrating. We filled the room with the ritual phrases that keep panic out. The data pulled down into Gordon's pipeline, where the code wore a kind voice: standard star OK. Flat OK. Object S/N, 64.3. Polarization, 0.48% plus or minus 0.12. Then the second angle. Then the third. By dawn the curve had enough points to have its own character. It did not become cometary when it should have, not even at the phase geometry that once charmed reluctant dust into showing its lean. It remained low, smooth, polite. On the board polarimetry stayed stubbornly in pending, though the caret beside it crept a shade toward fail. "Leave the humility in," Gordon said over the speaker, a smile audible through fatigue. "The sky may just be shy. Shy skies we could accommodate. Silent ones were another matter." November 16, the first quiet nudge. We worked the deep spectroscopy in parallel from Hawaii, drawing out the night with integrations that had no mercy for circadian rhythms. Near UV and blue channels begged the quantum throats, CN 388 nanometers, C2 swan bands, to sing. They did not sing. Our software stacked, subtracted, teased. Yoon walked the thresholds down, then up again, like someone checking the locks before bed. By dawn, spectra pending with a note in small type: upper limits improved times 1.8 versus October block, no lines, 3 sigma. The whiteboard acquired a strip of tape marked repeat November 18. When the universe averts its gaze, the only answer is patience bordering on superstition. November 19, the first pass that wasn't. Instruments don't remember anniversaries, but humans do. 19 days into the campaign, with the sun 4 fingers lower in the sky than when we began, morphology came up for its first serious verdict. We pushed the imagers to absurdity, 240-second frames trailed along the object's motion vector, then reprojected and co-added in its co-moving frame. We threw every trick we had collected over careers: PSF subtraction, rotationally symmetric residual filters, faint tail boosters that could make a galaxy out of floor dust. We found nothing that rose above false salvation. A hairline suggestion appeared in one stretch, a brushstroke anti-solar. Then we reversed the stretch, randomized star fields, rotated our own bias out. The stroke became superstition. Ghost, the imager said. We marked morphology pending again, with an underline that expressed irritation rather than doubt. Show me something, the underline said. The sky did not respond. November 23 to 25, the instrument humans. You can't film numbers for 2 hours and call it a story, so the camera that shadowed us learned the faces that made numbers move. Yoon's pen chewing when a line refused structure. Nilsson's habit of whispering please to a telescope as if it were a queasy child. Gordon's cheerful profanity, geographic in flavor depending on his home hour. The graduate student's fingers tracing the constellation on a laminated star chart as if the paper itself could improve seeing. The dock crew asked for voiceover lines, we kept giving them instructions instead. Frame at start of track with +2 pixels buffer in RA, +1 in DEC, someone would say, and the editor would sigh, but keep the tape rolling. Over their B-roll, the narrator could describe the quiet as suspense, the screens as a glow against uncertainty. But the room, its smell, the faint burnt dust scent of electronics. The coffee gone metallic in styrofoam, told a truer truth: this was not a thriller, it was a long, careful stare. We crossed more days off the calendar. The zeros and ones trudged into arrays named for mathematicians we loved. Noter greeted them all without prejudice. November 28, a shape that pierced politeness. The moon took its meddling elsewhere. The sky granted us one of those nights that makes you superstitious about domes. Our polarimetric curve, now better sampled, did a small, unexpected thing: it twitched. Not up into comet family territory, that would have earned a chime and champagne. Instead it developed a phase-dependent scallop, the faintest rippling consistent across 2 instruments. When folded with a provisional rotation period, the scallop tilted toward a model where cross-section varies on a clock, as if something presented more face and then less in a rhythm that liked the sun. Rotation aliasing? Gordon suggested. Could be, Yoon allowed, but it holds when I punish the period search. We were not ready to write poetry about it. We were ready to enlarge the note on the board. Under polarimetry pending someone printed, scallop persists. The room accepted the phrase with the same caution it now reserved for words like discovery. December 1 to 3, the week of good machines. The first week of December felt like a metronome. Instruments opened where they should, scripts did what they were told, and the sky behaved as if it liked us. We cashed in on that goodwill, 5 nights of deep imaging bracketing 1 spectral run. The morphology stacks burrowed toward surface brightness limits we had only joked about, each new radius out to which we could swear to the absence of a coma. By the 3rd, the imager drew a slow box around morphology and, with the solemnity of a judge writing the last page of a verdict, moved its magnet to fail. It sounded dramatic, it wasn't. It was arithmetic. A quiet settled, the kind that comes when one of 3 lives in your decision tree has been used up and the story still needs an ending. Someone made it official on the scoreboard: morphological coma not detected to X mu JY arcs X superscript 2, R band, tail absent at 5 sigma out to 20,000 kilometers projected, conditions, subarcsecond seeing, phase angles sampled 18 to 26 degrees. No press release. Not yet. Science prefers ensembles to soloists. December 4 to 6, the spectra that would not confess. We turned the spectrographs up to 11 and cut them off only when cryogens demanded mercy. Yoon rode the wavelength solution like a jockey, rechecking lamp lines with the obsession of someone who has learned that truth loves a calibration file. The noise grinned at us in its infinite masks. We stacked. We masked. We dissected residuals into bins and bled them down. We extracted the thinnest of continua and asked it if water was hiding there like a half-remembered melody. Upper limits, again. Lower than before, again. The threshold marching toward the hypothetical outgassing rate that could carry the observed delta V, but stubbornly above the number that would make the case clean. We printed the plot and taped it beside the scoreboard, where the spectra magnet hovered on the seam between pending and fail like a hand not ready to leave the door jamb. 2 more shots, Yoon said, and the room, uncharacteristically, nodded in unison. December 7th, a small, graced glint. At 3:12 Universal Time Coordinated, the wide-field monitors caught it, a microflash, below any sane threshold for tweeting but above the nonsense you attribute to clock hiccups. It appeared in 2 latitudinally separated stations within 0.3 seconds, same pixel offset within tolerances. Not a satellite. Not a cosmic ray. A flick. Specular reflection? If you liked the radiation pressure story, you fed the glint into your priors and smiled. If you didn't, you called it coincidence and turned the page. We did neither. We logged it, we circled it, we reminded each other about bias. Then we set an alert for geometry that would make such flashes more likely. The scoreboard did not have a magnet for maybe. If it had, the glint would have owned it. December 9th, the fit that started to lean. We refit the trajectory including the latest astrometry. Waiting to punish our favorite sins. The residuals, those tiny, stubborn leftovers that carry the world's personality, did a slant thing. They shrunk when we allowed the cross-section to change with phase and the pattern our polarimetry now claimed to half see. Don't fall in love with a fit, Gordon repeated, this time to himself. We're not, Nielsen said. We're admitting the fit loves us. This was the dangerous place science visits when it's been well-behaved for too long, meaningful models offering better numbers, discipline asking you to remember that better numbers are not the same as better worlds. We moved nothing on the board. We drank more coffee. We walked outside and let the cold make us precise. December 11th to 14th, the last of the pendings. The penultimate polarimetric night pushed the curve to where even reluctant comets give their secret away. Ours didn't. The degree of polarization stayed low and steady, with the scallop now evolving into a full shallow wave folded over the rotation period. 2 independent pipelines agreed, a third, Gordon's deliberately hostile code, would only concede feature persistent under phase randomization. We let ourselves update polarimetry at last, a muted move to fail, qualified with an asterisk. In the margin we listed the asterisk's terms: curve not dust family, shallow rotational modulation suggests cross-section control. The board looked almost relieved to have certainty, even pessimistic certainty. 1 test remained. Spectra. December 16th, the floor drops quietly. We threw everything at the last spectral run, longer integrations, tighter tracking, adjacent band imaging to catch any dust we'd spent a month failing to see. The object obliged by being bright enough to hurt and dim enough to dare. No CN. No C2. No H2O. The upper limit bands bit cleanly below the mass flow rate needed to supply the observed thrust by gas alone, even assuming perfect momentum coupling and heroic collimation. There was a small ceremony that wasn't a ceremony. The spectromagnet, at last, moved to fail. A sigh followed, not of drama, but of calculus completed. A comparable story would have popped confetti. We printed a plot. The TABL0 that looked like a verdict. We retired the word litmus, the tests had exhausted it. The scoreboard became what it had promised, a table that did not care for our feelings. Cometary jets, fail. Geometry hiding activity, fail. Morphology, fail. Polarimetry, fail. Radiation pressure dominance, pending, glint candidates, 1, rotational wave, persistent. Thermal recoil augmentation, pending, IR lag below detection, insufficient alone. Electromagnetic coupling, pending, low prior. Systematic error, fail. There was power in admitting how much had died. There was more in refusing to champion what lived simply because it lived. We turned back to the one row that refused to pick a side. If radiation pressure dominated, it would leave a signature on the path, not just as a small constant shove, but as a controllable variable. The fit that preferred a changing cross-section, the glint that would not behave like a cosmic ray, the polarimetric wave, all small, all individually insufficient, all arranging themselves like notes that want to be a chord. We set the trajectory monitor to display a second curve, not just where gravity alone took the object, but where gravity plus a modulated light push nudged it. The lines ran almost together, as if flirting, then began to peel. That's when the room acquired a sound we hadn't heard yet. Not gasps, our culture doesn't like those. It was an old, human exhale we reserve for when a field we thought we knew moves under our feet. December 17th, the pivot. The object's outbound track began to flirt with a set of solutions that intersected the Saturnian system not by accident's wander, but by an angle that made geometry whisper to itself. The acceleration residuals cohered, oscillatory, small, but peaking when the phase favored more sail to sunlight, fading when it didn't. Gordon pulled the lever he always pulls when the math starts making poetry. He changed the axis labels to something heartbreakingly banal. Residuals versus solar phase. The curve still did the thing. He tried residuals versus time in days. It did it there, too. Don't say it, Yoon warned. No one's saying it, Nielsen lied gently. We pinned up a printout of the solar system from the perspective of our epoch. A thin thread traced the object's predicted arc. 2 arcs, actually, the gravity only one, cold and indifferent, and the curve that allowed a humanly modest amount of cross-section steering. The second brushed a swath of orbital longitudes near Saturn that did not care for coincidence. We watched the lines and invented mature ways not to use certain verbs. December 18th, the convergence. The night before the hinge, the pass/fail board lost its last restraint and went live, each magnet echoed by a console field that shifted without human intervention as thresholds were met. A silent light flicked to fail beside spectra before anyone thought to announce it. Morphology remained in its grave. Polarimetry glowed with a small red dot that, once clicked, would deliver the hostile pipeline's admission, feature persistent. And the trajectory monitor did an impolite thing. It drew a thin, real-time marker where the latest fit said the object was going, and the marker steered toward a plane of space that would, within 2 rotations of the Sun around its own axis, put the traveler into a corridor where Saturn's gravity could take a polite bite. This can still be natural, the graduate student insisted, not incorrectly. Light curve aliasing. Unknown thermal. An osculating everything. Put them on the table, Nielsen said. Make them as big as they deserve. And then make them smaller if the sky asks. We added 3 new notes to the screen, not to the scoreboard. Notes are humbler. Check alias degeneracy versus uneven sampling. Cross-correlate residuals with space weather, again. Simulate high-porosity frost scenario with anisotropic albedo. The simulations came back exhausted and unpersuasive. The frost loved being bright when it should be dim and dim when it should be bright. The space-weather correlation remained the whisper it had always been. The aliasing grudgingly admitted that it could not fake the coherence the sky was now offering. December 19th, the hinge. It was a Friday where we were, a Thursday where others watched, a day on calendars and a night on telescopes. The dock crew put the camera on its tripod and didn't move it for hours. The coffee went cold. The jokes faltered and then, wisely, stopped. At 2:11 Universal Time Coordinated, the monitors chirped, not the chime of a line crossing a threshold, but a polite beep we'd invented to save our nerves, new astrometry ingested. The residuals adjusted. The 2 curves, the indifferent path and the modulated one, leaned apart another fraction of an arcsecond on the screen. The Saturnian corridor narrowed its smile, confessed how reachable it was. At 3:08 Universal Time Coordinated, the wide-field glint watch almost earned its nickname. A second microflash, weaker than the first but time-coincident across 2 longitudes, cut a brief notch in the background. We logged it, we swore in 3 languages, we did not enlarge it beyond its tiny worth. At 4:36 Universal Time Coordinated, the polarimeter stopped being polite and presented the rotation-folded wave so clearly that even Gordon's hostile code sighed and conceded, feature persistent at 4 sigma under rotation folding, morphology of wave consistent with cross-section modulation. The scoreboard refused to move radiation pressure dominance off pending. It is not a romantic object. At 5:02 Universal Time Coordinated, the ephemeris fit we had punished for days gave up one last scrap of pride and minimized with a smaller chi superscript 2 under the model that lets sunlight be an engine when a certain attitude was held and not when it wasn't. The residuals did not go to zero. This is not a children's book. They simply behaved as if someone were trimming a sail. We did not clap. We did not pronounce. We did what practitioners do when awe shows up wearing numbers. We checked the clocks, we ran the alternative, we rebooted a pipeline just to make sure a pointer hadn't gone to memory it didn't own. And when the results survived our pettiness, we allowed the room to exhale. On the planetary plot, Saturn glowed not because artists had made it so, but because geometry makes everything glow when it's near being true. We authorized one change we had promised ourselves we would not dramatize. Radiation pressure dominance slid to a cautious pass, with a footnote so defensive it could only have been written by people who understood how easily they could be wrong. Pass indicates model coherence under independent channels, astrometric residuals, polarimetric wave, specular candidates, consistent with modulated cross-section. Does not imply intent. Does not imply artifact. Does not exclude hybrid models. We printed the footnote larger than the label. The decision tree, that paper forest we'd grown in Part 4, stood now with its blue crosses over almost every leaf that wore the words gas or dust. The amber circle around C, the sail that would not say its name, had taken on a kind of sullen authority. Beneath it we added a child branch with no label, just a question mark and a date. By midday UTC the outbound trajectory plotted with the new non-grav term threaded a corridor that any mission designer would recognize as not an accident, a set of inbound longitudes at Saturn where a body could skim the upper atmosphere, adjust, and then flirt with ring material without committing to a fatal plunge. It was preposterous to say it. It was irresponsible to say otherwise without acknowledging that preposterousness had a slope in its favor. We framed it with discipline. The doc narrator would later recite the words we drafted: a course bent by light alone can, under precise geometry, resemble intent. We are not saying it is intent. We are saying that the numbers now align with a path that does not apologize for resembling it. Nielsen looked up at the proposed corridor and refused poetry again. We prepare for contact like signatures, she said, or we abdicate our usefulness. No abdications. The Part 6 checklist was already in a shared folder. It had been since summer, a superstition masquerading as diligence. Dusk, local, the red bulbs already switched on. We were about to sign off for a 6-hour maintenance window when the trajectory monitor coughed up a tiny additional courtesy, a fit variant with a lower assumed mass, suggested by new photometry, tightened the corridor further. The speculative path now grazed a narrow slice of latitude above Saturn's equator that one of Gordon's interns, who should have been sleeping, recognized from a classroom poster. The mid-B ring gap, he whispered, then caught himself. I mean, a region where ring particle density is lower. A safer. We don't say safer, Yoon reminded him quietly. We say less immediately suicidal. We turned to the last thing in the room that still had power to change the temperature, the alert scheduler, a gray box of buttons and acronyms. Nielsen hovered over Engage Part 6 protocols and didn't touch it yet. Instead she looked around and counted the eyes. On the record, she said, voice calm as weather. We will treat the next 5 days as if the object intends to interact with Saturn's system in a way that will mimic control even if no such control exists. That means synchronized instruments. That means pre-approved public language. That means knowing the difference between awe and evidence in our own throats. Around the room, one by one, we nodded. The red bulbs hummed. The night outside draped itself over the domes like a promise you make only to keep. On the screen, the two curves, gravity alone, and gravity plus the soft hand of light on a wide, obedient skin, parted just enough to be undeniable. We did not know what the sky would do next. We knew, at last, what we would do if it did. And somewhere far beyond the black, an object we had taught ourselves not to name adjusted its face to the sun in a way our instruments could now hear, not as sound, not as story, but as the plainest thing science ever gets to have, a small difference that stays. In the morning, the protocol button would be pressed. For now, the cursor hovered, waiting, as the ringed planet turned its cold, bright shoulder to meet whatever the dark had decided to send. They pressed the protocol button at 6:02 Universal Time Coordinated, and the room changed temperature. No applause. Just the practical music of an orchestra tuning all at once, hot swaps on the storage array, battery checks for the portable photometers, a chorus of copy and affirm and go that braided 3 continents. The scoreboard, which had been our conscience, became our clock. Above it, a fresh strip of tape read, Saturn window T84HRS. On the far wall, the solar system plot that had once been decoration now behaved like a live organ. Saturn's pale ellipse swept its path, a ringed geometry lesson in motion. Over it lay 2 threads from Part 5's last fits, the cold curve that cared only for mass and gravity, and, beside it, a line with a slight, unnerving intention. That second path threaded a corridor of longitudes where, if an object were to glance the tops of Saturn's atmosphere and trim a sail made of nothing but sunlight, it might emerge with a vector that flirted with the mid-B ring sparser lanes. We did not nickname it. You don't nickname a diagnosis. Checklist Step 9, Nielsen said. Cross-instrument trigger rules. The rules appeared on every terminal at once, spare and unromantic. If wide-field glint watch detects coincident flashes at greater than or equal to 2 stations within plus or minus 0.5 s, then increase cadence of rotation phase monitoring by ×2 for the next 10 minutes. If astrometric residuals drop by greater than or equal to 20% under the modulated cross-section model during a geometry that implies more sail, then spawn polarimetric sweeps at phase offsets, plus 0.1, plus 0.3, plus 0.5. If radio spectrometers detect narrowband spikes plus or minus 3 kHz from predicted ring particle plasma frequencies for greater than or equal to 5s, then tag event candidate ring interaction and lock all rights for audit. On paper, it looked dry as dust. In the room, it sounded like bracing a door. How do you film a distance? The dock crew wanted to be near us when the notional contact came, near the long faces of people taught to keep their mouths still. They wrapped lav mics over sweaters and hid spare batteries inside the hollow where coffee cups had lived for a month. They had learned that telling our story meant watching light bounce off our faces when numbers changed. We couldn't film the approach itself, no camera could, but we built a choreography for the sky to play, in Chile, the polarimeter's analyzer stepping like a second hand around its circle, in Hawaii, the Echelle spectrograph's lamps less aglow than a low hum, in Spain, a small radio spectrometer aimed just off Saturn's rings to use them as a mirror for the stray fields that often tell on high-velocity dust. Defocus test completed, the imager said. PSF characterization stable. Glintwatch awake, called someone on the wide field channel. Clouds to the south but the northern station is clear. Rotation phase? Nielsen asked. Entering quarter phase where the polarimetric wave should crest, Yoon replied. If it's a sail, it likes this shoulder. The narrator in the edit bay would later speak over these lines, making poetry of their bluntness. In the room, the poetry remained a debt we would settle later. Geometry narrows its eyes. At T 63 hours, the modulated model folded our newest astrometry and leaned again, just enough to make fresh coffee ritual, not comfort. The corridor at Saturn tightened to a ribbon. The fit that allowed cross-section control, the polite name our papers would use, reduced residuals not only when the apparent area increased, but when its orientation liked the sun. Axis obliquity constraints, Gordon murmured, writing numbers so small the pen complained. If it's a real modulation, you're looking at a stable attitude regime. We do not say attitude, Yoon replied automatically. We say orientation that behaves like attitude, Nielsen amended. Professionalism had taught us tongues that could thread needles without breaking skin. Saturn's globe, on the other plot, grew from classroom icon to a weather system. The upper atmosphere, a place of H2 and He with a thin lace of hydrocarbons, would be thin as a prayer at the altitudes we were considering. A graze there would be more like a handshake than a burn. We had written it that way in the protocol. Any contact, if contact occurs, is consistent with a short, stabilizing exchange of energy in the exosphere. We were careful. We were not cowards. T48 HRS, the room agrees to lean. The polarimetric wave we'd tasted in Part 5 arrived now with the stubborn clarity that only persistence makes. Folded over the rotation period, the curve's shallow modulation crested and rolled exactly when the cross-section model demanded. The hostile pipeline, the one we had trained to hate our favorite results, stamped it persistent and piped that verdict to the board without comment. Beneath radiation pressure, the asterisk inherited a second asterisk. Add the hostile's opinion to the footnote, Nielsen said. The glint watch registered nothing we could love. It logged a pair of false positives, spider on a lens, satellite at the field's edge, and reset its thresholds without sulking. This was what discipline looked like, 100 observational acts too modest for narrative acquiring their own sort of grandeur. We slept in shifts, or pretended to. The bite that leaves no teeth marks. 19 hours. The object would, if our numbers were not betraying us, reach the edge of influence where Saturn's upper air could stroke its skin. You can't watch a gas touch a thing from a billion kilometers away. But you can watch the consequences make themselves visible through other people's eyes. We set 3 classes of sensors to listen for signatures that belong to contact-like behavior. Atmospheric skim, a brief, wavelength-dependent dimming as sunlight scattered through whatever column the object had chosen to cut. Expected duration, seconds to tens of seconds. Signature, a shallow, achromatic notch with a long, whispery tail if the object pitched just so. Stabilization chirp, tiny, periodic changes in the polarimetric curve as drag torques kissed a rotating body and damped some modes faster than others. Signature, temporary reduction in wave amplitude at specific phase lags. Ring brushing, temporal spikes in reflected radio or narrow optical bands as ring particles, disturbed locally, produced microplasma puffs. Signature, narrowband radio spikes bracketing a predicted plasma frequency, in optical, a faint, diffuse brightening along an azimuth that would rotate with Saturn's field. Remember the language, Yoon said, eyes on the room rather than the screens. Consistent with. Compatible with. Keep verbs humble. 19 minutes, someone announced, and the room tightened itself like a fist without closing. The first signature. The first to move wasn't the board, or a monitor, but a thin plot in the corner, a photometric light curve that had been so flat for so long we had named it tabletop for quiet fun. At 3:12 and 14 seconds universal time coordinated, tabletop dipped, only by a hair, only for 20 seconds, only in a way that might have made a poet eye the room and a statistician leave it. Achromatic, shallow, present. Then the curve resumed its patient line as if nothing had knocked at its door. Cloud? The imager asked. The infrared cloud cam showed a sky so clear it looked like a lie. Instrumental? Yoon asked the pipeline. The pipeline returned a small shrug of green ticks. Schedule the post-mortem now, Nielsen said, because that is what you say aloud when your heart is doing a dangerous thing. The dip alone would have earned us nothing but a paragraph and an eyebrow. But T03:12:37 brought a second sign, and if this is a film, that is where an editor would cut to faces. The polarimeter's shallow wave, our quiet metronome, took a glottal stop. Its amplitude, measured in a unit so small we always had to remind ourselves it was real, reduced by 20% for a handful of rotations, then crept back, shy as it had been all month. Damping? Gordon said, not daring to put a name to it. External torque? Say external influence consistent with damping, Yoon replied, unblinking. Mark both, Nielsen said, and the board obediently lit two square LEDs near candidate ATM skim and candidate stabilization without moving any magnet a millimeter. There was oxygen we hadn't realized we'd been holding. We let some out. Ring Ward. If the geometry we hadn't dared to name was true, the object would, within the hour, pass through a longitude where the outer fringes of the B ring spread themselves thin. A lace that, very briefly, could be disturbed in a way even earthbound sensors might notice if the sensors were pointed and patient. In Spain, the radio spectrometer operator tightened his grip on nothing. The scope had no hand controls, but humans like to hold something when something might happen. He tuned to a frequency band a teacher would call textbook and engineers call home. The plot stuttered, then soared, no broad storm, no screaming burst, just three narrow spikes that rose like exclamation points aligned with a marching band. Plus 2.8 kHz. Minus 1.9 kHz. Plus 3.1 kHz. Duration, 7s, 5s, 9s. He swore without flavor and hit the log button 3 times in a row as if the first two hadn't counted. Coincidence time, he asked aloud to no one and everyone. Within 0.6s of predicted transit through the diluted lane, came the reply from the cold code that hated theatrics. Across the network, a small optical tube riding piggyback on a bigger one did a humble thing. It counted extra photons from a faint, diffuse patch just off the ring edge, the sort of brightening that makes you wonder whether your calibration lamps had been cynical. The brightening rotated, a tiny, patient movement that matched the field's turn like a child turning a page. The board did not have a fireworks magnet. It had a quiet label we had printed weeks ago and never thought we'd use, ring interaction candidate, triple source. It lit without sound. We still did not say contact. We said, event consistent with localized ring disturbance temporally correlated with predicted trajectory. We printed it on a label maker that complained about the length but obeyed. The vectors respond. If any of that was real, and reality in our trade is always provisional, the flight path should show it, not as a heroic kink, not as a pilot's flourish, but as a whisper that the residuals would notice. We ingested the new astrometry, applied the punitive weights we had learned to love, and watched the two curves adjust. Gravity only tightened its jaw and stayed indifferent. The modulated cross-section model bowed by 1/10 of a degree in a direction that would make an orbital mechanic nod and a scriptwriter swear. If you wanted to, you could deem it a trim. If you were careful, you could call it a vector change consistent with energy exchange. If you were a coward, you could call it noise and move the goalposts another inch. Don't let the vocabulary do the thinking, Nielsen said, soft as a night light. We marked the change, and then, because that is how the covenant works, we tried to break it. We scrabbled through systematics we had exiled weeks ago. We beat on every miscalibration and assumption like a rug flung over a line. The blip did not leave. It stayed where geometry said it should stay and refused to be charmed into leaving by our suspicion. Outside, the wind moved the dome's skin with the weight of a hand. Inside, our own skin remembered that awe is not a conclusion. Natural, if you're kind. By dawn at one site and midnight at another, we had 3 signatures that, together, made a shape you could not ignore, a shallow, achromatic dip, a temporary damping in a rotation-folded polarimetric wave, and 3 narrow radio spikes coincident with a predicted pass through a diluted ring lane. The trajectory fit, when allowed the modesty of light as a force, improved with a bow where physics would let air be thin and ring particles be shy and the sun keep its long, indifferent hand on a wide face. Could a world do this to a stone by accident? Possibly. We sketched the accidents with professional tenderness. A high albedo fragment with a frosted, porous skin and a talent for thermal lags could mimic some of it, if its rotation axis were just so and its aspect were biased toward brightening at the wrong moments. We had punished that model for days. It bled under the tests and smiled less under new data. A temporarily bound debris cloud traversed by the object could give you the dip and a radio signature if the cloud were in the right place for the wrong reasons. Our rings are not static sculptures, they are weather. But the timings were the kind that made if stand on its toes. A space weather flourish, an electromagnetic tantrum, could give you radio spikes most any midnight it wanted to if you were not careful about correlates. We had been careful. The correlates refused to behave like tantrums. All three models went on the board under supported and disfavored and insufficient columns we had left blank since summer. The chalk moved with a restraint that looked like kindness until you read the words and realized it was just accuracy with its coat on. We have to say something, and say it right. Part 7 begins now, someone said, meaning protocols rather than pages. The communication draft, thin paper with thick words, moved to the center of the table. We had rehearsed this paragraph and yet it felt new in our mouths. We report a set of independent observations, photometric, polarimetric, radio, that are individually marginal but mutually coherent when interpreted within a model that includes a small, rotation phase-dependent cross-section term. These observations are consistent with a brief interaction between the object and Saturn's upper atmosphere and a localized disturbance in a dilute ring region. We do not claim intent. We cannot exclude natural mechanisms. We will publish all raw and reduced data with method sufficient for independent reproduction. No one liked the word intent. We left it in. You cannot disinfect a word by refusing to use it, you can only make your relationship to it honest. Public standard of proof? Yoon asked, and it wasn't a rhetorical exercise. Higher than ours, Nielsen said. Ours is to move the field, cautiously. The public's is to not be moved without being carried. On the scoreboard, the pass/fail/pending tricolor had no space for rhetoric. It had only a new row we'd been avoiding and had to write now, steady angle. We did not move a magnet onto it. We put a piece of tape over it that read out of scope. Then, in a smaller font, not forbidden to think. Somebody laughed, then apologized. No one told them not to. Late in the watch, while one crew slept and another pretended to, the wide field station in the south called in Glint Candidate 3, a small, sideways lick of light that lasted longer than a blink and shorter than a breath. It was only seen at one site, and that is the sort of thing you don't live on. But it came at a rotation phase the polarimeter liked, and the fit that behaved like a sail liked it, too. Coincidence does not become causality by showing up with friends, Gordon said. His own mouth tilted at the edge as if it might not obey. At some point, Yoon replied, the friends become a neighborhood. We tagged the glint and did not move anything. The domes hummed. The ringed planet went on with its business, a day 10 hours long, a hexagon at its pole that did not care about our narratives. We closed a few loops, left others strolling, promised the data it would be hurt rigorously and tenderly until it told the truth that stayed. The night's last ingests finished their small negotiations with our API, and the trajectory plot redrew itself with the patience of a scribe. The two lines, the cold one and the one that allowed light to act like a hand, parted by a distance that would not trouble a layperson and would keep an orbital dynamicist awake. Saturn, in that plot's calm projection, showed the hush between its rings like the space between sentences when someone is about to admit something hard. The corridor we had feared and hoped for was no longer a corridor but a seam, thin as mercy, straight as a vow. Telemetry, the radio operator whispered, saying a word that didn't belong to us because there was no craft to send it. Old dreams ride the tongue when the present invites them. Nielsen looked from the plot to the faces and back again. She touched the tape that covered SETI angle with a finger as if reminding herself it existed and must remain covered, then turned to the camera that had recorded all our careful sentences and our shame at wanting to say larger ones. "We will not claim more than we can carry," she said, voice barely above the room. "But we will not fail to carry what we can." On the ring map, a faint, irregular brightening, too faint to announce, too regular to ignore, began to march with the planet's rotation like a small rumor learning how to be a fact. And in the space between the two convenient words, natural and not, there opened a narrow lane we would have to walk in daylight, with the world watching. At dawn we will write the paragraph that takes this from our mouths to everyone's eyes. But between now and then, the object has one more configuration to try, a turn of its face toward the sun that, if the model holds, will decide whether the next plot we print looks merely elegant, or uncomfortably deliberate. They printed the paragraph just after dawn and pinned it to the noticeboard like an oath. The room, which had learned to distrust applause, allowed itself the smallest ceremony. Lids clicked shut on pens, a kettle exhaled, somebody murmured, "Good," without explaining whether they meant the words or the restraint inside them. On the board, we left the SETI angle row covered with the same piece of tape. We wrote a date on the tape now, December 20th, and beside it a promise, out of scope, not out of mind. Out in the quiet, Saturn turned its shoulder and did not look back. The paper we would not live in. The preprint went up before lunch. It did not feel like publication, it felt like stepping out under the sky without a coat. Title, a sentence long and accurate to the point of ungainly. Author list, wider than a doorway, with instrument teams who had learned each other's phone voices by heart. Abstract, a map with guardrails. Conclusions, one paragraph shorter than anyone wanted, and therefore the right length. We report, independently marginal, mutually coherent, consistent with, localized disturbance, rotation phase-dependent cross-section term, cannot exclude natural mechanisms, all data and methods released for independent reproduction. No italics. No italics were needed. Beneath the text, a link to an archive with passwords already disabled. Folders named with the tidy cruelty of a well-run lab: astrometry, photometry, polarimetry, radio, calibration, logs, hostile_pipeline. Inside hostile_pipeline, a readme that began with the sentence, "This code is built to make us wrong." At the bottom, a license that let rivals use it without asking and required them to keep the warnings attached. It was, in its way, an invitation to be contradicted. The first email arrived 12 minutes later from a team in South Africa. Another from a small observatory in Arizona wrote, apologetically, that they had pointed at Saturn on a lark and had something that might be nothing until our plots taught them its shape. A message from a spectroscopist in Japan asked a single, surgical question: "Do your residuals still shrink when we force the non-grav terms phase to lead solar azimuth by pi/4? If yes, why?" We did the calculation and wrote back, "No. They grow. It sits closer to zero phase." A relief, yes. Also a narrowing. The quiet that follows a shout. The rooms we had filmed so often, Chile's white-walled control, Hawaii's warm-paneled night, Spain's cramped radio shack, learned new sounds, the scrape of chairs for conversations about standards. The field didn't need a hero, it needed a grammar. Nielsen took a piece of paper and wrote 3 headings, each with a box that could be checked only with evidence, not with hope. Supported. Results that survive hostile replication by independent pipelines on independent data, with uncertainty quantification that remains conservative even when authors are tempted to get brave. Disfavored. Hypotheses that are not impossible in principle but that require a coincidence of geometry, timing, and context tighter than our experience of the outer solar system has taught us to accept lightly. Insufficient. The honest middle, where data gesture in a direction but do not take your hand. She left a 4th box unlabeled. We knew what it meant. We would not let the word fill the room until the evidence could carry it. Yoon drafted a section for a style guide nobody had comfort making yet, public standard of proof. In sharp, spare language. We respect public imagination. We will not recruit it to fill our gaps. Where our models require a novel agent, we will publish not only the fit improvement but the penalty we assign to the novelty. Where our words could be mistaken for intent, we will replace the verb. Journal editors wrote back with interest that read like relief. The good ones had dreaded having to referee a fight between awe and caution. We handed them a scale with weights already calibrated, adding a term to the future. The far plainer work occupied most of our hours, making sure that what we had typed into a paper found its way into the machines that would not remember our names. Forecast cones for minor bodies, and the rarer, stranger ones we now watched with a different posture, would gain a column. It would not be called mystery. It would be called a non-gravitational term with rotation phase dependence, a plug-in that allowed the sunlight to act like a whispering hand on wide faces. The code had thoughts about what to do if the term went to zero: smile and say, "You're a rock," and if it widened to absurdity, warn the user that they were asking light to do the work of a small engine. We argued a full day about defaults. This is what adulthood looks like in a field, not the drama of a discovery, but the tenderness with which you set a switch. Gordon shepherded a working group whose title was longer than any one person's patience: Task Force on Cross-Section Modulated Non-Gravitational Acceleration in Interstellar and Long-Period Objects. 8 time zones of scientists learned how to listen to each other past the delay. They settled on test suites, canonical comets that should not light the term, notable weirdos, 67p, with jets like a seltzer, Halley, with its humors, that must trigger it, and a synthetic population of sail-like bodies that could shame us if our math grew lazy. Pull requests started to arrive from strangers who were now becoming colleagues. One wrote from a hospital bed. Another apologized for typing with one hand while her baby slept on the other. The code took their offerings without caring, the credits page remembered. Risk, but with measurements. Consequences ripple outward as protocols before they congeal into policy. An operations group out of Bologna wrote a memo with a sentence so sober it was almost funny. Although the likelihood of engineered non-gravitational control remains unquantified and possibly small, the cost of being wrong in the presence of such a thing, especially if maneuvering intersects planetary systems, demands a minimal alerting framework. Minimal, not dramatic. We could live with that. They sketched 3 alert levels. Watch. A public tag applied when a body's trajectory significantly improves under a rotating cross-section model, with the caveat that many natural skins can mimic the effect. No television required. Advisory. Raised when a temporal correlation appears among independent channels: photometry, polarization, radio, occultation, and geometry supports a skim or brush event with a large planet's environment. Communications go to professional lists first, public press follows with prepared sentences that borrow humility's vocabulary. Coordination. A rare state that does not shout "alien" and does not whisper "nothing," but asks agencies who steer spacecraft through the outer system to share their schedules, just in case. It comes with a sunset clause and a promise to publish even the embarrassments that follow. We hoped never to need the last one. We wrote it anyway. That is what responsibility looks like: preparing a shelf for something you would prefer to keep in a box in the attic. Talking where people live. By the second week, the footage we had been collecting since summer found its voice. The doc crew cut together the way a careful editor sutures: no swelling strings, no gaudy fonts, no loops of our faces at their ugliest. They let rooms breathe. They let the board, its magnets and tape, be the chorus. Nielsen practiced 3 lines for a camera that could not ask questions back. No, we are not claiming control. We are claiming coherence. No, one dip in a light curve does not change the world. Several independent signals that arrive at the right times change the odds. No, we will not adopt your headline. We will give you a paragraph you can use. They filmed Yoon cutting a phrase from the narration and writing: "We cannot exclude over, we do not think." It was a small act. It felt larger because we had not been asleep at the wheel when wonder knocked. We agreed as a group to avoid certain metaphors that turn questions into banners. No whales in the sky, no cosmic sails on purpose. We drafted alternative images, humble ones, a wide leaf in a long wind, a page held up to the sun, a door held just so against a draft. The public does not need us to shrink. It needs us to choose our scale carefully. Replication as a plot. You want an ending. The field gives you a loop. Arizona's small observatory reproduced the shallow dip independently, with their own calibration sins and virtues, offset in time because their sky had its own weather. Their dip was smaller. It still had the whisper of achromatic honesty. South Africa's team, after cursing a broken antenna and sleeping badly, found 2 spikes where we had found 3, their frequencies tucked near ours but not married to them. They sent raw. We rejoiced in their imperfection. Authentic data is messy the way living is. Japan's spectroscopist wrote again with a plot that made Yoon bring a hand to her mouth, a secondary polarimetric damping hours after the first. The phase lag fit a simple model with an external torque and a body of fractionally different moments of inertia. The hostile pipeline tried to throw it away. It could not. The label persistent added a comma to its own name and did not apologize for the grammar. A long-haired postdoc in Poland discovered that if you force the non-grav term to drift with a season inside the object's skin, a change in how heat walked through it, the fit cloned some of the elegance without earning the hardest coincidences. He wrote an honest sentence: "This is the first model you should kill before you adopt the adjective deliberate." We pinned his sentence above our coffee machine. A woman in her 70s, retired from a career in spacecraft operations, mailed us a printout of our trajectory plots with a protractor taped to it and a note in blue fountain pen: "If this were a craft and I wanted to skate a thin air at the edge of a world, this is what my trim would look like if I were refining rather than transporting. But rocks can do clever dances without our choreography. Keep your verbs tidy." We kept the note. The protractor stayed like an amulet. What we accept, what we don't. At month's end, we took stock with the merciless tenderness our profession requires. Supported. The existence of a small, rotation phase-dependent non-gravitational term in the trajectory model quantitatively improves fits across independent astrometric datasets. A sequence of independent observations, photometric dip, temporary polarimetric damping, and narrowband radio spikes, occur within predicted windows consistent with a skim of Saturn's upper atmosphere and a localized ring disturbance. Replications by external teams reproduce the pattern, even when amplitudes vary, and the hostile pipeline's negative controls fail to erase the coherence. Disfavored. Models that require a coincidental debris cloud at exactly the right place and time with exactly the right density to mimic both the radio and photometric signatures. Thermal lag models with phase offsets inconsistent with the observed polarimetric timing unless one invents a set of interior properties narrower than any we have measured in comets or small bodies. Solutions that call for a radiation pressure coefficient that, if true, would require albedos in contravention of observed colors and brightness histories. Insufficient. Any inference of control or intent. Our data speak to geometry, timing, and coherence. They do not have a grammar for motive. We wrote it down. We signed it. We put it where we could not avoid reading it when tired. Policies begin as checklists. We added 3 to our wall. Open methods, fast. Data drop within 30 days of detection events at outer planets that meet advisory threshold, with pre-registered pipelines and a hostile branch published alongside the friendly. Terminology lock. Once a public paragraph goes out, we will not change verbs without publishing why we changed them. This protects the public from narrative whiplash and protects us from the seductions of adjectives. Ethics of uncertainty. A short form, plain language, attached to every release that explains, in human terms, what we know, what we don't, and what would change our minds. It includes a section titled, Places We Refuse to Go Yet, and lists the words we are not ready to pronounce. It felt smaller than a discovery and heavier. Protocols often do. We did, finally, lift the tape on SETI angle, not to move a magnet onto it, but to replace it with a more honest title, External Agency Hypothesis. Under it we printed 3 rules. Never first. It is never the first model you test, it is among the last you cannot comfortably refuse. Penalty attached. Any fit improvement credited to this hypothesis carries a quantified penalty that reflects the novelty of the agent being invoked. Exit ramps. At every stage, maintain and publish conditions under which the hypothesis would be demoted or retired without drama. We returned the tape, not as censorship, but as a reminder that sometimes covering a word is the only responsible way to let the rest of the sentence breathe. 1,000 emails found us, most kind, some unkind in illuminating ways. The unkind ones taught us where our language had been porous. The kind ones reminded us why you do science in a world that can be louder than you like. Schoolchildren printed our ring map and colored the brightening with pencils that left wax behind. An artist in Lego sent a painting of a page held to the sun, the letters on it unreadable, the light around it deliberate. A machinist in Ohio built a model out of sheet aluminum that found its balance point where our fit liked it, and wrote, "I made it in my lunch break, but I think you're onto something." We read these between meetings about covariance matrices and learned to let both kinds of reading change us. If there is a climax in a story like ours, it is cold and focused, a night of plotting and a morning of a paragraph pinned to a corkboard. The real change happens later, quietly, as the things we decided to be true about how we work begin to propagate. Graduate students ran simulations with the new term and discovered that some of our past anomalies were simply places where we had asked rocks to pretend they didn't have surfaces. Postdocs learned to budget all like a scarce resource. Senior scientists learned to let juniors write the first drafts, because caution is easier to teach than courage, and courage, used with care, is what moves a field without breaking it. We updated syllabi. We retired a few reference slides that had been pretty but lazy. We stopped saying non-gravities as a joke. We caught ourselves, more than once, before we said impossible. What remains is not an answer but a direction. The corridor by Saturn became a seam, the seam became a sentence, the sentence became a protocol. There will be other objects. Some will be honest comets announcing themselves with the joy of a tale. Some will be hunks of dark stone drunkenly aphelion bound. A few may be wide leaves in long winds, doing dances that burn at the edges of our vocabulary. We are better prepared now, not to proclaim, but to listen in ways that preserve meaning. The final sequence of the film is unshowy. It is a montage of hands typing the words, we cannot exclude, hands pulling old plot files into new directories, hands affixing magnets to boards in rooms whose windows show different skies. Over it, the voice we train to stay calm holds a last sentence in its mouth. We do not know everything. But we know, more than we did, how to look. The last shot is a star field, unremarkable until the camera gently overlays a schedule, a list of forthcoming occultations by our object across faint background stars 6 months hence, small windows where a silhouette might tell us the size and shape we have been modeling at arm's length. Between the dates, June 7th, June 19th, July 3rd, someone's pencil hesitates, then circles a time with a quiet confidence that looks suspiciously like hope. If the light of a distant star walks along that edge and blinks in a way only a wide leaf could make it blink, we will know which verb to retire and which to keep. For now, we keep the humble ones. And we set the alarm.